Hello and Happy New Year. Welcome to the December slash early January monthly update. You're here with my colleagues, Tomasz, Juan, Ohad, and Andre. We're just going to give you the updates from December onwards up till now. At the end of this month will be the January update. So just going to follow on from just to basically we're just going to include the holiday period. Just a little bit late. So I'm going to pass it on to Tomasz, and he will give you his updates.
So hello everyone, and thank you. So in December, I've created an IRC bot, which allows anyone to use TML in a chat to create multiple databases and do intersections between databases of users to show consensus. Bot understands commands in TML itself. So it basically works as a TML REPL, which is a textual interface, which can be simply extended by an UI, or it can be simply integrated into another network or a software. The bot is still a prototype, and this is actually the first real program written in TML, even though it delegates some activities to system scripts. With features Dragan and Juan are adding, I'm going to move functionality from system scripts to TML. And then I'd like to make the bot updatable by its users. It means that I'll put the source code of the bot into the database, and if the code in the database changes, bot updates itself into the new version. So this way we will be able to collaboratively create the whole alpha.
Awesome, so, fantastic. Very cool. I'm going to put it over to Andre to take over next.
Hello, everyone. Last month, I was working on something I think I can show you right now. Just let me share my screen currently. Wait a sec. Oh, yes, this one. Okay, so as you see, this is one of the possible views of our user interface to have our discussions, have friends, request them, have both TML only discussions or natural English discussions. The magic behind it is that I was able to automatically catch all subclasses, upper classes of the entities user mentioned, and you can see it here. For example, when you say you like cats, you translate it out, it translates automatically into TML and automatically upload all subclasses of, for example, dog is domestic animal, canine, etc., etc. So it will allow us on logic level to find some intersections between classes, types, between what users post their opinion on, and to give some real results out of discussions. Also, I improved the UI since we don't have UI guy yet, and you can come to this site and play by yourself. But it doesn't have any results yet. It does only have discussion. Yes, later it will be possible to add opinions. On opinions, as you see, I disabled it for now, but this is some work to do. And as most of you saw already, I've added a bot to play with. It's a bot that uses sentiment analysis and entity detection of text user posts on Telegram or IRC. And this will help us to improve our understanding of logic behind discussion even more, one way or another. So that's it.
All right, I am going to put it over to Juan to take over with his updates.
So hi. Happy New Year for everybody. So last month I kept working on the arithmetic support in TML. We actually made the relevant progress, excuse me, regarding doing arithmetic over. We mentioned this in our last month talk. Doing arithmetic not on the full universe of symbols that might be represented in a TML program, but just on a subset of them. So this makes the arithmetic support further much more efficient in terms of space and evaluation time. So, for example, if we're evaluating the addition of instead of our domain being the full universe, just being two subsets of that universe. Let's say we have a set composed of 2 and 0, and we have another set B, which is composed of 1 and 3. So the output of the addition over those two subsets of the universe will be just 3. It's 2 plus 1, 2 plus 3, 0 plus 1, and 0 plus 3. That ends in a subset C, which will be 3, 5, and 1. So we managed to implement that over BTD, so over subsets arithmetic, in particular for bitwise operations and for the addition. We are very close to complete that feature for the multiplication. We reached the end of the year with that feature not fully working, so we are still bouncing with some implementation issue for that. But I'm confident that we should be getting that feature in terms of the multiplication operation fully functional in the next few days. So hopefully for next month we will be sharing with you that we get in particular the multiplication of the subsets fully functional. So I keep crunching bits with the BGDs for the arithmetic support, and that has been my main focus during last month.
Fantastic, amazing. I look forward to that. Okay, so on my side, I can keep it quite short and sweet because our lawyers want us to be a little bit stum until they put out the statement. But in terms of percentage of the legal aspects that we needed to solve, we've taken quite a big step. And I would like to be able to put out a public statement now myself, but that has to come from our lawyers. But hopefully I can do that pretty soon. We're just waiting for them to draft their statement for us, and then we can put it out and publish it on our website and show you guys what we've been up to over the past couple of months in solving these legal issues. So I'm going to keep it short and sweet from me in that respect. Yeah, hopefully I can get back to you with the lawyer's statement pretty soon. All right, so I'm going to put it over to Ahad to give you his updates.
Thanks, everyone, and hello, everyone. As you heard, we had such a nice progress this month. You saw the GUI that Andrei showed you, such a nice GUI for discussion platform, and you can already imagine how the functionality that Tomasz implemented this month is going to get a nicer form, and it's also going to get easier form. As Andrei showed you, he gets into the natural language world in a way to help users that they will not need to express themselves only in formal language, but something closer to English. So we achieved this important milestone in 2019 to have consensus detection working. It really made me happy. Umar, after he finished the previous month, the parser for first and second order logic formulas, he implemented transformation of formulas to pre-nex and conjunctive normal forms. When he will come back from his vacation, he will work on the context-free parsing abilities of TML. In particular, Umar is an expert in this very field. Dragan enhanced more the built-in support that he already made. And he's working on a very important fundamental change in how the implementation of TML works by making it flexible to change the bit order. After all, BDDs are all about bits, and we currently have some rigid ordering of bits. Once we will be able to make it dynamic, we will be able to support types. And everything will be much more intuitive, especially with negation. When you say not something, you can associate it to some universe. And it will also be very helpful performance-wise, because right now, because of this lack of dynamic encoding, we use more bits than we really need. And the more bits can translate to exponentially larger binary decision diagrams. Okay, and now for me, this month, I had a lot of administrative things to take care of, and also a lot of conversations with the team about technology and the plans. But in research, I, of course, continued with second-order logic. I was investigating the ability to use reflection, which is reflection is an important property in programming languages in general. It's a very common term in the world of programming languages. So in TML, it gets an interesting form to reflect the interpreter's internal data to the programmer would mean to reflect the BDDs. So this may give rise to many interesting features. I was also researching the important point to bear in mind, which is that we all know that Turing machines, or not necessarily Turing machines, any other model of computation, for example, a random access machine, which is a model closer to our computers, those models are infinite by definition, and therefore they are not really realizable. And of course, our physical computers don't represent them. Now, if we still stay in the theory and we take a Turing machine or random access machine or any kind of such machine, and we limit it to have a fixed amount of memory, then, well, the intrigued listener can look up and see, one, why the halting problem for such machines is decidable. And second, to run such a machine is a task doable in polynomial space, and it is a task doable very directly in TML, because random access machine or Turing machine or automaton are basically only transitions relations, and those transitions relations are nothing more than 4-array or 5-array relations. So this means that to simulate a machine with constant memory can be done in TML as it is right now. When we will have second-order logic, we will be able to synthesize programs from requirements. But to simulate some assembly language even that takes into the assumption fixed memory is doable in TML right now. And this has huge implications. This means that we can take any program in any language and compile it to TML. It will not be equivalent, but the point of equivalence will never be practically visible, because it will be exactly when we run out of memory. So practically it will never reach this point of equivalence. And by that, we can compile operating systems, even TML itself, and have the self-interpreter this way, this automatic way. We can do so many things by converting arbitrary machine code to TML. So this was also a thing that I dived into this month. Another thing is to, all the time we speak about the alpha as a discussion platform, and we are for all good reasons always interested in some incentive or gaming mechanism to encourage users to participate in the platform and to formalize knowledge. So I was playing with the idea of having a debate platform with some kinds of points that by that we can get some metrics and some incentives to knowledge representation. This is just a generalization of discussion platform, because discussion is just a debate without a winner and without a loser, formally speaking. Okay, so and that's all for this month. That's all for now. Thank you very much.
Fantastic. I also just want to add that we also have our white paper coming soon as well. It's something that I forgot to mention. I'm reading drafts of it right now, and I like it a lot. So I'm very much looking forward to getting that in your hands. I guess Ahad will give the final say on when everything's ready, but we expect it to be pretty soon. All right. That's it for now. Stay tuned for the Q&A questions. I'm sure there's going to be tons. And thank you for listening. Hello, and welcome to the Q&A. We have a couple of questions from Red Neve, so I'm going to get right into them. He says, does the current version of TML support decidability, negation, and self-reference? If so, are you able to show it by concrete examples, for example, on GitHub or the website?
Yes, the current version of TML support the three laws of laws, being decidability, self-reference, and deletion, which can be seen as some kind of negation. However, TML also supports negation, not only deletion. And again, I refer to TML as it is right now, which is basically a pure PFP. You know what, even less than pure PFP, it's a language that is called P-Datalog in the literature, for example, the book Finite Model Theory by Ebbinghaus and Flum. In fact, just today, I spoke about it a lot on IRC, so maybe you can see some more information there. To demonstrate this, well, let's start this decidability. Decidability amounts to showing that all TML programs always halt. Well, how can I make you a demo showing that all programs always halt? Yeah. It's not something, by the nature of the thing, it's not something that you can show by an example. But to get convinced why indeed all TML programs always halt is not hard, and it is explained in the README on our GitHub. And I also touched on it on IRC today. And if you try to read the README and you get questions, of course, as always, anyone can ask me anything. So that's for decidability. Decidability is by nature, it's not something that you can demonstrate by example. Now, so for self-reference and for negation and for deletion, you can see it already. if you put the negating operator on bodies, then you can see that already in the bot that already running in TML assays, that negation simply works. Same for deletion. And for self-reference and recursion, you can see that indeed TML does not restrict you in writing recursive predicates, in writing things that depends on themselves. So I guess that's all. I guess that's all for this question.
Red Neve asks again, are you open to any partnership with big companies that will be interested in your technology? And I'm sure they will be.
Yes, definitely. I think that once the products are out there and are much more mature, we will get a lot of attention, maybe even too much attention.
All right. Another one from Red Neve, sorry. Now that we are in 2020, are you able to give a more concrete planning of releases?
Well, I can promise you one thing, that if I ever had any number in my mind, I wouldn't spare it from you or from anyone. What I don't know, I simply don't know. Just today we spoke on IRC about the theoretical. I don't want to get anyone into dreams, but to the theoretical possibility that after we have something initial that allows collaborative development, then things can happen very fast. Very theoretically speaking, to build Tau and Agoras and many more things, 10,000 people can do overnight. So once we have this basic system of collaborative development and critical mass of developers, even before we finish the whole roadmap, things can get very, very fast. But that's really apropos the conversation we had today. To your question, at the moment I will have a number, I will not spare it from anyone.
Okay, fantastic. Is there something that you wanted to implement in Tau, but you couldn't? What was it, and why could you do it?
I'm coming from the world of mathematics and science, and we could really use entities that are smarter than us. We very quickly feel the limits of the human brain, and there are a lot of things that indeed our brain is a bottleneck we cannot achieve, because we do have such a small brain that we cannot discover a lot of medicine, we cannot engineer a lot of things, we cannot solve a lot of problems in mathematics. So, but fortunately, one thing we can do, we can build things that are smarter than us. And that's what we want to do.
Will we build a database from scratch, or will we import existing data? For example, RDF data.
Well, of course, I or the team, we cannot force any knowledge base on any user. Any user will have to deliberately choose the knowledge paths that they adapt. But of course, they will be able to adapt a lot of existing knowledge bases. That's true.
Another one by Red Neve. They say, there is no truth in Tau, just opinions. Does this mean that there will be multiple databases with each one its own truth, and we can choose in which database universe we want to integrate into Tau?
Definitely, Tau has to be designed such that everything on Tau is relative to the user looking. and their worldview and the worldviews of other users that decided to share with that user. No user will typically be informed of everything that happens all over the network. So yes, it is all relative.
What's the current power of the server-side alpha? For example, can it endure 1,000 requests per second without affecting the user experience? Do you plan to increase its power before the first release, or will it come in future releases?
And there is no currently server for the alpha. There will be a temporary server that will not really do any processing. It will only route messages between clients. And by that, it will not suffer from bottlenecks and will be easily scalable. But it is indeed temporary because our end goal is, of course, peer-to-peer network. In such a network, there will be no server in a fully decentralized network.
How many users do you estimate that we need, at the very least, to benefit from the alpha functionality? And also, from how many users will it get more interesting to use the alpha instead of your typical 4?
Well, of course, I don't know, but I think that we can draw inspiration from Wikipedia. The average person doesn't write articles on Wikipedia. Nevertheless, Wikipedia grew from some core of people who took seriously the process of formalizing knowledge. Also in Wikipedia, they formalize knowledge just in a different way than we refer to on Tau. What would be the critical mass that could make Wikipedia grow? I don't know, but I guess it's same orders of magnitudes that are relevant for Tau.
And this question is from RW, and they say, do you have any prediction of what AI will be able to make once TML and quantum computing are fully developed? By fully, I mean that the tech is mature and therefore there won't be any remarkable breakthroughs.
Yes, well, that's what everyone called the singularity when we reach such a stage. And this, by definition, is beyond our imagination because it's all about AI, which is many levels beyond us. So we, by definition, cannot predict what it will do. And of course, trivially, you could find people to describe the singularity so much better than me and thought about it so much better than me. But this sounds to me like the stage you are speaking about.
And Dana asks, it's been said in chat that in order for TML to be used for programming, it needs to have the ability to call executable procedures. Will that be made possible?
Yes, Dragon already made the support for built-ins, and one of the main requirements from the built-in systems of TML is the ability to load any DLL and call any C function from it. So indeed, you could basically call any function from any executable function from any code from TML using the built-in mechanism. It is not completely finished, but it is getting there.
Tempest says, Dear Ohad, can you give us an example of a global knowledge base being used by a company?
Yeah, I admit that I try to recall, and I even spent some time searching in order to give good answers for this question. But I couldn't come up with any example. I will need to think about it a little more, to search a little more. I say, it is clear that many do so. You asked about companies, and I had in mind governments, so this doesn't answer your question. I'm sure that Google and Microsoft have a global knowledge base, but I cannot put my finger on any of such. I will hopefully search more and be able to give you a more full answer.
And this question is from Dean T. They say, Do you know of other companies working on similar projects?
About similar project, well, depends to which level of similarity. No one try to tackle the problem that we tackle in the way that we do it. We speak about collaboration in a logical setting that satisfies the three requirements of law. This thing no one does. No one that I believe that really no one. A software that is governed by its users under a decidable framework is also not something that I think anyone is working on. So to sum it up, there are projects in tangent fields, for example, in knowledge representation, in logic, but knowledge representation and logic are tools. And I'm not aware of anyone using those tools to solve the problems that we intend to solve.
And this question comes from Gustav. And they ask, how does Tau compare to Wolfram? What does Tau intend to do that Wolfram cannot?
Indeed, there is a big difference between Tau and Wolfram. Wolfram is a tool to discover truth, to represent truth, facts about the world, mathematical facts, physical facts. While the concept of truth is completely alien for Tau. In Tau, there is no truth. There are only opinions, which is something that Wolfram doesn't have. Wolfram is simply not intended for this use. Tau is first and foremost a social product. It's about the ability of people to communicate and to collaboratively reach decision. I am not aware of Wolfram Alpha has anything to do with collaborative decision making.
And the final question is from Dana Edwards. And he asks, can you go into a bit more detail about how the language translation feature of TML is intended to work? Will it really be any formal language to any formal language, or are there specific criteria restricting which languages can translate to which?
Yes, I start from the second part. Ultimately, of course, it is impossible to translate any language to any language. I could take the language of all Turing machine and ask to translate them to the language of 0 and 1, 0 if the machine halt and 1 if the machine doesn't halt. And that's of course impossible because the halting problem is undecidable. So of course, in the general way that you stated, of course it is impossible. However, when we say language translation, practically, we don't mean to use language translation to cheat and to really refer to something else, like to solve the halting problem. We usually refer to a much more concrete and easy computational tasks. So of course, TML will not do everything because, again, it is impossible, but it is intended to do the common tasks that people encounter when they translate documents from one language to another, formal languages. Now for the first part, how is it going to be like? We have a document in some source language, and we have a TML program that is supposed to translate this document into some target language. So the process would be, this TML program will typically be composed of two parts. One part will define the grammar of the input language, and then this grammar will be fed into TML's parser, and the parser will parse the source document and produce a parse tree or a parse forest. And that's where the parser ends its mission. And then comes logical rules, as we know in TML, that manipulate this parse tree or parse forest by adding or deleting nodes. And by that, we form the target document, and that's it.
All right. Thank you so much for all of your questions. As always, we will see you in Telegram for any follow-up questions that you might have. And we will see you in the next Q&A at the end of this month. Thank you.